Hello, everybody, and welcome to this pre-stress webinar. My name is Flavio Popescu. For those of you who don't know me, I am a structural engineer at Strusoft, Denmark. Today, my colleague Ciprian Tsiba will help me with the questions you might have. We will use this online platform called GoToWebinar. If you haven't used it before, you have the GoToWebinar window in front of you. So in this window, there is a section called Questions. Here, I will ask you to type in any questions you might have during the presentation. This way, my colleague, Ciprian, will be able to see these questions and answer them. So, once again, if you have any questions during the presentation, please feel free to ask them there. Of course, at the end, we can also take them individually. And since we are not too many people attending today, it will be possible, I think, to have a live chat using microphones. So if you have a microphone connected to your computer, I will be able to give you access and be able to speak if you raise your hand. There is this really nice feature called Raise Hand, and that way I will know that you have a question. I believe there's also this chat function where you can type in anything at any time. Today we're going to look at the pre-stress software and how you can handle double T-beam design with this program. So I'll just open pre-stress here. For those of you who see pre-stress for the first time, this is what it looks like. And the first thing that happens when I open the program, I am asked to select a national annex for my Eurocode. I have here several national annexes. If I can't use any of these, I will also have the option to use the standard one and then customize my parameters, which I'll do right now. I'll just select standard and click OK. Here is the main input window where I can enter a name for my element. And I will just say double T 101. Give it a length. Let's say 12 meters. And here is where I choose my section. I can see that I can model basically every section that I want. I can have rectangular and variable rectangular and all these shapes that you see here, including hollow core elements. I have tackled this type of element in a different webinar. So if you want to see that, you can actually access that on our YouTube channel. Maybe we'll take a look later where that channel is on YouTube. But for now, I will choose this T section. And I'll choose this size right here. Click OK. First thing that I want to say is that, as you might have noticed, pre-stress only considers half of this TT section. So it only considers one T. This means that you will also have to adjust your loads according to that. So take into account only half the loads that you would actually apply on a double T beam. What you can also do is have a sloped T beam. So this is also possible. If you have, like, for example, a roof structure which is sloped like this, you can also choose a variable section and edit these types of sections here and make it according to your model. But today we'll just use a constant section for now, at least, with these dimensions. And when I'm ready, I can just go ahead and click Add. Right here from the beginning, I choose a default fire load combination to be created for me. So I can also take a look at the fire design. Here is the project tree with my element. If I have several elements, which I can actually have in pre-stress, they will be listed here underneath. Each of them with their own load combinations and stages. I can see here all the stages from release up to the final stage in ULS and fire combination. For my element, I can define the reinforcement and tendon distribution. This can be done in several ways. One really good feature, which is the reinforcement pattern, allows you to use a predefined pattern. This can be created. There's also a default one in pre-stress, but you can also create your own patterns and save them. So that way you will have this pattern already created for your element, and then it will be easy for you just to select the places, these slots on the pattern where you want your reinforcement to be inserted. So just to demonstrate just how easy this actually is, I can actually put some reinforcement here, and then I can just add it, and then I can return to my reinforcement pattern and continue to add elements. Let's say that I want these to be some strands, some tendons. Again, I can just go back and choose some more reinforcement and then just add it there. I'm going to use some massive reinforcement here. Let's say I'll add a few more up here. 2 more up there. Oops. So this is an easy way to just add reinforcement. It's very useful to define different types of reinforcement. If you want pre-stressed, pre-tensioned tendons, or if you want just regular reinforcement, you can easily do it with this reinforcement pattern. You also have this layer of reinforcement tool, which is also a useful tool. This way you can just type in the number of bars, and then the program will automatically add them down here. I'll just keep this configuration for now. Maybe we'll look at it later with different types with different methods of adding the reinforcement. But for now, I like this configuration, and I'm going to keep it like this. So I have some tendons here. I can also see it in my table. It is also possible to edit this table and adjust my reinforcement accordingly. Okay, I have some stirrup reinforcement here. It is possible to calculate it and design it automatically. So pre-stress will calculate it automatically for me. And this is something that is to be taken into consideration. The fact that the program will calculate and design the stirrups, and it will give you a group area in millimeters square per meter. So it'll give you a distribution and a necessary stirrup reinforcement, but it will give it in millimeters squared per meter. So it will give you the correct area, but it is up to you to place it afterwards as you please, and according, of course, to the code. So I will allow it to design it manually and see what my reinforcement, my stirrup reinforcement is. Then I have the reinforcement details here. I can set up my covers and details. Calculation settings here. I can perform a check for splitting, spalling, and bursting. Also have these pop-up messages here for more information about these different options. For fire, I can set up some fire time and just consider fire from the bottom side. And I can also set up my calculation sections. So I've basically defined the geometry, the reinforcement, and my calculation settings, including fire calculation. What I can do now is set up my loads. Again, I have these construction stages here, which are set up by default with exposure class, life class, and strength class for the concrete. Of course, I am able to choose the desired classes that I need for each of my stages, and also the strength class. If I go to input loads here in my top menu, I can see that the self-weight has been automatically assigned, so I don't have to put that. I will add a few more load cases here. So I will say some screed, which is also permanent load, and then I'll just say office. As you can notice here, I can choose the type of my load, and you will see in a second why this is important. I'll just say okay for now. I'm happy with these loads that I've created, these load cases. My self-weight is already applied. I'll just need to assign my other loads. I have the screed load. Then I choose my stages where I actually want that load to be placed. And I have the option to put uniform load, trapezoidal load, point loads, and self-weight if I actually selected not to have this automatic self-weight. So I'll just go ahead and put some uniform load. As I have a T-beam, I can have my loads in square meters, in a kilonewton per square meters, a surface load. So what I need to do is actually reduce it to a line load, and I will place it, I'll give it just the value of 1.9 kilonewton per meter, and then just apply it for my stages where I want it to be. By default, this line load is added in the center line of my element. I can also do this for the office. Let's say add some 25 for this one. And again, I place it for my little stages. as I was saying, this by default is placed on the center line of the element. I can also place it with eccentricity. For example, I want to have it a little bit to the right or the left of my centroid. So if I just have it 30 centimeters, I can also place, let's say, just place 20 kilonewton per meter to the right and just add it here. And hopefully I can just select the other one. Yes. It's this one, actually. Okay, I'll put it again. Oh, in millimeters, yes. So I'll just put 30 millimeters. And I can see that it is actually placed with 30 centimeters from my center. So I also have the option to calculate with eccentricity, which will give me some torsion moment. Okay, I can also see an overview of my loads, and I'm okay with that. Next up, I can set up my load combinations. I have here the long-term parameters, which I will not add that right now, but this is also a possibility to add creep coefficients and shrinkage for long-term effects, which by adding them here will be taken into account. But let's set up some load combinations, and I can do that really fast just by going to my specific stage and then selecting my load cases. Pre-stress will add the correct factor here for each of the load case according to the national annex. So this can be done really fast automatically. I just have to click change. Of course, it is also possible to type in manually your coefficients and basically write any type of equation here for the load combination. But I'm going to use this automatic function in pre-stress. Okay. So I have my loads, I have my load combinations. I can go ahead and perform a calculation. If I go to calculate analysis and set an analysis. This is a warning, actually, that my covers are not set up straight since I've added them. I can also just go back and change that. I will still have a calculation performed, but just as a warning that those covers are not met. I have here a bending moment. I have some torsion as well, since I've had that force with eccentricity. I have some shear force. And I also have deflection. Then I can just perform a design according to my internal forces and deflections, which I got from this calculation. Here I see an overview of my utilization for my stages. I have green, which means that everything is fine, and then with red, of course, that means that something is wrong. I can easily identify this just going to the code check and see what what check doesn't verify. I see that I have some compression stress in the release and storage here. 1.55. So I have high compression stresses. I can deal with this now with using my engineering judgment and say that my compression forces are too high. So I either decrease my force or reduce my tendons, the number of my tendons. But here is a good place to see what actually happens and see the utilization for all of my stages. You can see that I also have a small misutilization above 1. So I have all of these checks and verifications after my design. I also have some tables with the bending. I can see here if I have any cracks. I can see that for stage 1 means uncracked, stage 2 means cracked. So I have some cracks from the release. I have temperature gradient for my fire combination. I can see here that everything that is outside this line is a damaged zone. So the temperatures are very high, so the concrete is considered destroyed. So it doesn't consider it anymore in the calculations. As well, I have here some reduced concrete parameters due to fire action. For the reinforcement as well. Yes. It is possible to calculate recess in the beam as well. If you enter the dimensions for this recess and enter the bars that you want put here at the end of the beam, you can have a verification and a calculation here in the output. Let's see if I can actually get one to see how it looks. LR 300. That's the length. That's the height. That was the width. Okay. Thickness. Let's see if I have input is faulty revise. Okay. Don't remember exactly what this was. Oh yeah, I put 2.2. Of course. It's the web width. So I can get these calculations here. And verifications. So I can also perform this recess beam verification at the end of the beams. The documentation report is generated automatically. If I just choose some sections for my fire calculation, it just starts generating my calculation report for me. So while I wait that, I'm going to see if there were any questions. There are some questions here. And Ciprian is handling them. These, okay. Okay, great. Again, if you have questions, please feel free to ask them in the questions section. As I said before, we also have this option to have a chat. So if you have a microphone and you feel you want to ask a question directly, you can actually raise your hand. And I'll see here, so I can give you access to the microphone. Yes, Norman.
Hello.
Hello, Norman.
Hello. Hello. Thanks for the explanation about the TT beams. My question is about the documentation report.
Yes.
If we go to the distribution of the stroops.
Yes.
Exactly. One page up, I think. It should be on page 39 or 37. Up more a little bit.
The distribution was here.
Right.
Is this what you mean?
Yeah, yes. But more explanation per meter. I want to see exactly how we can adjust those by in meters. I think it should be on page 38 or 30. Up more about, go to 37.
Left-hand reinforcement.
Around there.
Shear
You can
capacity.
stop there.
Okay.
Yeah.
Yes.
Exactly. Now we can see that. Yeah. Required. This is which is required, and current. The current stroops here, and which is required. Sometimes minimum. Is it really very important to satisfy the minimum reinforcements?
Well, that's a requirement from the code. So if you have a minimum requirement, even though the calculated reinforcement is less than that, you would still have to put the minimum.
Okay.
So that means that the shear force would actually be small, and the required reinforcement for that force will be less than the minimum in the code. So even though it's less than that, you would still have to put it, because that's the requirement.
Well, it's the code, the requirements for the code.
Yes.
But sometimes it can be a lot of reinforcements, and you feel that it is almost a wastage. In some cases, I've experienced, I had a beam, but it was so much reinforcements whereby I had to reduce them, but I knew that I could take responsibility for that.
Sure.
Yeah.
Sure. Yeah. It's yeah. I guess it's up to you to put it, and then you can also add it manually. So you can even if it gives you this necessary reinforcement, you can also go back and edit this stirrup
in the settings.
So exactly in the geometry. If you go back here, stirrup reinforcement, you get this setup of reinforcement, which is calculated by pre-stress automatically. But then you can also change it.
You can change it to see if the design is okay.
Yes, exactly.
If we go back to the documentation report, there was another.
Sure, I would need to make another calculation for that. So.
Yes.
Have you been using pre-stress long?
Yeah, for quite some time.
Where do you use it?
I use it on TET beams and on slabs.
Yeah.
Right now I'm working with the slabs, a lot of slabs. And but each time you come to such a online webinar, you learn something new.
Yeah, sure.
So there is always something new which you can learn. But I've been using it for about 6 years now, I think.
Okay.
6 years, and yes. Again, it was about, but in this case, we don't have a topping, so maybe it's not really, you not understand what I'm saying, because we didn't have a topping on the T-beam. It was about the shear force in the topping reinforcements, actually.
Yes.
And
maybe we can look at a specific example afterwards. So
exactly. If you put on a topping, then sometimes you're required to put in a topping reinforcements.
Yeah.
There was something which I'm working with the slabs right now, but the principle is the same. If we have a topping and they have topping reinforcements, so it was like that. If you have some time over, we could make an example and I raise a question. Yes. Sure. Thank you very much. Thank you very much.
You're welcome. You're welcome. Okay. Yes, Ian. He types a question down in the question field. Okay, actually, I'm okay. There's actually some construction work being done here in the building. Maybe you can hear the noise. I hope it's not too disturbing. There are some questions that are being typed here. I'm not really sure if everyone can see them, but we will send them after the webinar. I can also send them with the question and the answer by email, so everyone has access to them. Please, if you would like to try pre-stress, if you're not using it yet already, go to strusoft.com/products/pre-stress. And here you can find more information about pre-stress and what it can do. Get a trial here by going to Get Started, trial license, and then filling out this form. So you will receive a trial version for pre-stress. It cannot design columns, Cobus. You can you can set up it in a way that you can have these supports to act like a column and then put some forces here. But that's the best you can do. You cannot have, you can't really set up a vertical element. We have other programs for that. Actually, you can use WinStatic. If you go to strusoft.com here, this window, yes, products, WinStatic. You can actually have these types of elements here. It's for beams, columns, and frames. This WinStatic is similar to pre-stress. Jan, these two values mean vertical and horizontal displacement. So this is horizontal, this is vertical. That's why you have two values here. Yeah. If there are no more questions, Norman, yes, you have another question?
Yes. Yeah. How can you make a fixed end on one of those, for example, during election montage?
Yes. Let's see. So select this one, and then if I choose this one,
yeah,
support, and then I fix my
X coordinate and the moment. Yes.
Yeah. It's fixed then. So I can set it up fixed.
Okay. So how do you handle those tendons? You have to probably to think about to reinforce that support in the sense that you get a negative moment, maybe?
Yeah.
Somewhere there.
Yes.
Okay, but it is possible.
Yes.
All right. Yeah.
Okay.
If you have some time over, we can make an example where you have a topping. I would like to see actually about the reinforcements in the joint.
Yeah.
Yes.
Yeah. Sure. Great.
Yeah. Thanks a lot.
Thanks for your question.
Yeah.
Okay. If there are no more questions, I'm going to end the webinar here. Remember to go to our website and get a trial at strusoft.com. Also follow us on LinkedIn for posts and news about our products. Thank you very much for attending, and I wish you all a pleasant day. Bye-bye.